I'm very happy to introduce the first keynote speaker of today. It's Michel Bitbol. Michel is one of the first researchers who tried to make sense of quantum mechanics by ways of phenomenology. So his work had a great influence on me. He also contributed to this relationship between phenomenology and cubism that has been very fruitful the last year. A volume on phenomenology and cubism will come out in December, where also Michel contributed a chapter. So Michel, it's my great pleasure that you will be giving this talk, and the stage is yours. And at the moment you're muted.
Yes, okay, thank you. Can you hear me now? Yes, I'm sure you can hear me. I hope so. Is it okay?
Yes.
Good, okay. So it's a pleasure to be with you today, even though by these web means. So my talk will be about the meaning of reconstructions of physical theories. And this meaning is precisely to give meaning, to try to give meaning to quantum theory, especially by deriving it from principles that are supposed to be much more primitive, much more elementary than the usual axioms of quantum physics, which are a little bit ad hoc. And so in this purpose, they are very similar to transcendental arguments, as you know, Kant was the first author of. So, okay. So first, I want to introduce you the concept of transcendental arguments for those who are not very familiar with this concept. Transcendental arguments is one of a wider class of what we can call backwards arguments, namely arguments from the consequence to the premise, from the consequence to the precondition. The strongest variety of backwards arguments is precisely the transcendental argument. It's very strong because it says that if X is a necessary condition for the possibility of Y, then given that Y is the case, it logically follows that X must follow too, must hold too. So that means that we derive a necessary condition for the possibility of Y. There is only one way for this deduction. But there are also weaker varieties of regressive arguments, two of them being Peirce's abduction and also the well-known inference to the best explanation in contemporary philosophy of science. So according to Peirce's abduction, the reasoning is the following. We observe fact Y, but if hypothesis X were true, Y would follow. Hence, there is reason to think that X might be true. Why is it weaker than the standard transcendental argument? Because there can be many X's from which Y follows. In some way, we could say that X is underdetermined by Y. So, but at any rate, Peirce insisted that this procedure is creative because it means that you elaborate something new and try to deduce what is observed out of this something new. Even though it is not secure, it is not, you are not absolutely certain that X is true, you have something that is new in science, and this is the most important according to Peirce. Inference to the best explanation is very similar because you choose the hypothesis or theory that best explains the available data, and in fact you think that because it's probably the best one, then you have to retain it. And the criteria to say that it is the best are essentially simplicity, unifying power, and rootedness in the most general conditions of knowledge. Okay, so usually transcendental arguments have been taken as a therapy against skepticism. And it was the case in the original version of our transcendental arguments, namely Kant's, because Kant was trying to overcome Hume's skepticism, David Hume's skepticism. David Hume's skepticism was exercised against applicability of a priori concepts of understanding to sensory experience. And Immanuel Kant showed that these a priori concepts were conditions of possibility of our even having experience, and therefore it was impossible to completely avoid them. It was not a matter of contingency if they were implemented. It was really necessary for our knowledge, for our very concept of knowledge. As in particular, the second analogy of experience, which bears on causality, diffuses Hume's skepticism about causality. You know that Hume said, oh, there is no causality, there is only habit of association of one antecedent to a consequent. But Kant showed that causality, our applying causality to phenomena is a condition of possibility for experience of objective of an objective surrounding. So it's not possible to just dispense with causality. Peter Strawson tried a deduction which is much more ambitious, but perhaps weaker than Kant's, because he tried to demonstrate the existence of an external world by means of a transcendental argument. He said, okay, let's suppose that you think of experiences as your own. Then you must be able to think of them as experiences, namely as opposed to what they are experiences of, namely objects. Since you presuppose this distinction between experience and what they are experiences of, then you are bound to accept the existence of an external world, which is what is experienced. So in some way, he thought he had deduced transcendentally the existence of an external world. But very soon, many authors criticized this very strong ontological claim about transcendental arguments. And they said, especially Barry Stroud said, that these transcendental arguments cannot prove the inherent existence of laws or objects, but only show that we must behave as if we believed in them. So for instance, we have to believe in causality in order to order the field of phenomena into an objective set. So in fact, what these features of experience presuppose, it is not real laws or real objects out there, but that's just that we anticipate phenomena by means of a law-like structure or by means of an object-like order. So we have to presuppose a law-like order or an object-like order. A transcendental argument is not about the existence of anything, but about the necessity for us to presuppose this something. And this is exactly what Kant said at the end of the day, because he said that the laws of understanding that he had transcendentally deduced are just rules for seeking a phenomenon in experience and a mark for discovering it there. That means that it's, these laws of understandings are not things that exist out there, but they are rules for us. norms for us to seek phenomena in experience. We have to use these norms in order to organize our experience in such a way that we can share it and speak of it and elaborate an objective knowledge out of it. So this is certainly a limitation of transcendental arguments, a very strong limitation, but it offers an alternative program for justifying physical theories. So here you don't no longer justify physical theories by their supposed faithful mirror-like correspondence with an alleged external reality, which would be just realism, but you justify physical theory by the fact that they implement in their formalism the elementary rules of anticipation that underpin both active cognition and experimental scientific research. So the theory is a sort of summary of the norms you use in your everyday or scientific action. So it's what I liked to call, after Karl Otto Appel, the doctrine of transcendental pragmatism. So you see that the general scheme of a transcendental argument is this backward scheme from Y, which is an incontrovertible fact of experience, which you take as a starting point, and then you derive the condition of possibility of these facts. But you know, in history, there have been many levels of facts. Some facts are just experimental facts, and other facts are very elaborate facts, such as, for instance, the givenness of a theory. In Strawson, you have seen that the starting point is very elementary. It's just the fact that we self-recognize that we have a subjective experience. It's very basic. And then Strawson wanted to derive from that there are objects of experience. In Kant, he takes something already more elaborate. He accepts that we have experience of objects, and he tries to seek what is the condition of possibility of this experience of objects. And the condition of possibility of this experience of objects is the set of a priori laws of pure understanding, such as substance, causality, and reciprocity, and also the forms of spatial and temporal intuition. I have also another example which will be useful for us. It's the example of Francisco Varela, who started with the experiments on elementary cognition of animals and humans, and showed that the condition of possibility of this type of cognition, even very elementary cognition, is the capacity by a living being to anticipate in his or her body, namely in his or her attitudes, behavior, what the animal will meet in the future. And what the animal will meet in the future is not just phenomena already given out there by nature, but it's a set of actively produced phenomena. So this is very interesting because it comes very close to cubism, as you will see. You know, but there is also a more elaborate way of using the transcendental arguments, is to start from a corpus of theory and come to deduce the condition, the formal condition of possibility of this body of theory. For instance, Newton did something very similar to a transcendental argument when he was asked by Huygens what was the formal condition implemented in the law of gravitation for saving Kepler's laws. And he found his laws of classical mechanics, which were partly derived from Galileo, and also his law of gravitation, which is in inverse square of the distance between bodies. As for Kant, we have seen that he started from experience of objects and went backwards to the a priori laws of pure understanding, but he also started from Newtonian mechanics and showed that the necessary conditions for Newtonian mechanics were very similar to the necessary condition for an experience of objects. And this was very crucial in his inquiry, because the aim of Kant was to give the basic metaphysical condition for the possibility of an efficient science of nature. Now, we come to the group of what we can call the reconstructors of quantum mechanics. And they do exactly the same in principle. They start from quantum mechanics as it is, and they go to very elementary condition of the possibility of such theory. For instance, they show, and we will see that more in detail later, that they show that just imposing a framework of unified formal anticipation, plus supposing that phenomena are contextual and actively produced, is enough to derive most of the structure of quantum mechanics. So let's see in Kant's transcendental deduction of Newtonian mechanics in a little more details. So as I told you, the starting point of experience of objects and the starting point of Newtonian mechanics give the same set of necessary preconditions, namely the a priori laws of pure understanding and the a priori forms of intuition. This is a very strong result because this shows that Newtonian mechanics, according to Kant, is essentially the most precise and careful expression of the very possibility of having an experience of an objective world. There was also a very particular transcendental argument that Kant formulated. It was about the form of his law of gravitation. So let's start from Newton's law of gravitation, namely that the force decreases in inverse square of the distance. And Kant noticed that this law corresponds closely to the degrees of the density on the surface of a 3D sphere, which increases as the square of the distance. So, in fact, according to Kant, the law of gravitation posited by Newton has as its condition of possibility the a priori form of the intuition in space, which is three-dimensional. So it's a weak but interesting form of transcendental argument. So let's see a little bit more precisely how Kant went from the givenness of Newton's theory to the principles of the understanding. He started with what he thought were the three Newtonian laws of mechanics. According to Kant, these three laws of mechanics were the constancy of the quantity of matter, or the mass, the principle of inertia, and the equality of action and reaction. In fact, there is a little discrepancy between Kant's three laws and Newton's three laws, but as it can be shown, they are equivalent. And then he showed that, in fact, the three laws were equivalent to the three analogies of experience in his critique of pure reason, which are implementation of the principles of the understanding, namely the principle of permanence of a substance, the principle of succession according to a rule, which is called causality, and the principle of reciprocal action. So there is a close correspondence between what can be called the metaphysics of nature as formulated by Newton in the approach of Kant, and the principle of fundamental understanding of human beings when they are confronted to the necessity of elaborating an objective knowledge. Okay, so let's come to quantum mechanics now. What is the meaning of quantum mechanics? There have been 4 historical conceptions of the novelty and meaning of quantum mechanics. The first one is what can be called the original view. The idea of Planck, and especially Bohr in 1913, was that quantum theory differs from all its predecessors in that it introduces discontinuities into the space of states of atomic objects. As its very name indicates, quantum theory is supposed to be characterized by just the postulate of quantization of its variables. So the idea is that quantum theory is a theory of the discontinuity of variables. But then other meanings were elaborated. For instance, when Albert Einstein reflected on the nature of light when he introduced his famous hypothesis of the quantum of energy, of electromagnetic energy, later called photon. There was the idea that in fact there was a dual nature of the objects of microphysics, namely wave and particle. So Louis de Broglie elaborated that for matter, after Einstein had introduced that for light. Then Schrödinger purified the concept in keeping only waves. And then he showed that it's possible to deduce quantization rules from pure wave-like clauses. So the idea was that, in fact, the real meaning of quantum theory was that it was a wave mechanics, hence the name given by Schrödinger to quantum mechanics, wave mechanics. Then Bohr and Heisenberg had a different idea, and I think that this is the deepest idea of all. It's that, in fact, quantum mechanics derives from a clause of relativity of determinations to the mutually exclusive experimental devices that define and assess these variables. And Heisenberg went so far as claiming that quantum mechanics pronounces the collapse of the Cartesian cut between res extensa and res cogitans. So the algebra of relativity and exclusivity may even yield the uncertainty, which is typical of quantum mechanics. It may yield wave-like effects, and it yields also quantization rules. From this commutation relation, you can derive all the rest. So presumably, Bohr's and Heisenberg's condition was one of the deepest, and you will see that the fate of the contemporary reconstructions of quantum mechanics is quite in agreement with this judgment. The problem is that there were ambiguities in this understanding, this new understanding of the meaning of quantum theory. The first ambiguity is that, you know, the basic move of the paper, the fundamental paper of Heisenberg in 1925, appears to be the systematic use of discontinuity. Namely, he uses finite differences between observable quantities. So it's a postulate of quantization. But then Born, Heisenberg, and Jordan, a very few weeks after, pointed out that the commutation relation is the only one of the basic formulae in the quantum mechanics that contains Planck's constant. Namely, the idea is what is more fundamental than the use of discontinuities is the algebra of the matrices of these discontinuous quantities. And the algebra of these matrices was precisely a non-commutative algebra. So according to Born, Heisenberg, and Jordan, quantization comes second after non-commutation and contextuality. The second ambiguity of the creators of quantum mechanics is that they hesitated about the meaning of their discovery. For instance, in 1927, Heisenberg thought it was necessary not only to derive his uncertainty relations from the commutation relation, but also to derive them from a quasi-classical model of disturbed particles in motion. And therefore, he reintroduced elements of a classical picture into quantum physics. So this was understood by a French philosopher of physics of the 1930s, 1940s, and 1950s, Jean-Louis Destouches, who was a student of Louis de Broglie at a time in which Louis de Broglie was following the lessons of the Copenhagen school, namely Bohr and Heisenberg, essentially. So Jean-Louis Destouches decided to go to the very ultimate consequences of the ideas of the Copenhagen school. He suspended every representation in every image, as Bohr would have said, inherited from classical physics, including the structuration of phenomena into a plurality of objects. He suspended that. And sometimes he spoke of objects as a complex of phenomena, just that. Then he suspended characterizations of quantum physics derived from such representations. He suspended quantization, waves, particles, disturbances, and so on and so on. And he came back to the most elementary function of cognition and also physical theories, namely that you posit rules of anticipation of phenomena, you posit a pure norm of expectation devoid of object-like structure. And you come back also to the most elementary feature of quantum phenomena, which is to be contextual, which is that they are impossible to divide into a contribution which is due to the apparatus and a contribution which is due to a putative physical system. And also the fact that these experimental approaches that allow you to trigger phenomena are mutually incompatible. And finally, Jean-Louis Destouches came back to the most elementary layer of Kant's transcendental deduction. Beyond all the categories, namely, you find a condition of possibility of all the conditions of possibility, which is the clause of unification of the methods of anticipation of phenomena. And Hermann Cohen, a neo-Kantian thinker German neo-Kantian thinker of the 19th century, claimed that very clearly. He said, what must be taken as a priori is not Kant's categories, but the category that underlies them all, namely the synthetic unity in the connection of the manifold of phenomena. So imposing the unity is the norm of norms in knowledge. And this is what we will see in the derivations of quantum physics. So you go from physical theory, namely here quantum theory, to its condition of possibility. according to Jean-Louis Destouches, if we admit with both that every experimental result expresses an isolated and unanalyzable interaction between systems and devices, a physical theory can only provide predictions for future experimental results under the condition of past results. Because you cannot say that there are phenomena which are already given out there. You produce the phenomena by the experiment, and therefore you cannot describe what there is. You can just predict the byproduct of your action. Here, prediction cannot be a byproduct of an underlying description. It is bound to be primary. There is prediction without description. This is the particularity of the situation of quantum physics. Then Paulette Destouches-Février, namely Jean-Louis Destouches' wife, proved an important theorem that any theory that deals with phenomena relative to context that may be mutually incompatible is essentially indeterministic. And therefore, the prediction you use in quantum physics can only be probabilistic. So the kind of theorization you have in quantum physics, you can prove that it is only a predictive one and that this prediction is only a probabilistic one. Okay? And therefore, Destouches then developed between 1936 and 1942 a general theory of predictions of which quantum mechanics is a particular probabilistic instance, and from which classical theory can be derived as an even more particular deterministic instance. A very interesting reflection of Jean-Louis Destouches is the following. He said, a physics in which certain pairs of simultaneous measurements are impossible cannot be a physics of intrinsic properties. It can only be a physics of pure relations. But relations between what? Between phenomena, between objects? Neither. It only provides us with predictions for future measurements articulated by certain relations, namely the relations which are imposed here are not between phenomena or objects, they are between the elements that allow you to predict phenomena. For instance, it can be relations between probabilities. Hence the name structural physics that we give to our theory. So Destouches was the author of a doctrine that we may call transcendental structuralism, as opposed to many other types of structuralism, such as structural realism or structural empiricism. Okay, now Destouches went very far in his attempt to reconstruct quantum theory. He showed that it is possible to analyze any prediction procedure in 3 steps, and that the third step itself decomposes in 3 other steps. Okay, I don't go into the detail of this procedure, but if you see that very closely, you realize that it is exactly the structure of quantum mechanics with Jean-Louis Destouches' predictive symbol representing the state vector, and for instance, the basic predictive symbols representing eigenstates, and so on and so on. Okay, what is important is that this structure was not just invented, it was reconstructed out of some basic requirements, among which there is a basic requirement to unify the rules for calculating probabilities across the diversity of experimental contexts. So there is a manifold of experimental contexts, there is a manifold of incompatible experimental contexts, but if you posit the condition of unity of this, of the anticipation of phenomena in all these contexts, then you are going back to the basic structure of quantum mechanics, including at least vector space, if not Hilbert space. Okay, now what is the function that connects predictive symbols to phenomena? In 1941, Destouches demonstrated a restrictive theorem showing that there exists a well-defined class of functions acceptable for probabilistic evaluations. But this was still a little bit, vague. However, in 1946, Paulette Destouches-Février used a generalized form of the Pythagoras theorem, borrowed from von Neumann, to offer a quasi-proof of the unique function that fits the bill, namely Born's rule, the square of the modulus of the coefficients of the decomposition of a certain vector space. This was a demonstration which came much earlier than Gleason's proof in '67. But whatever you may think of this proof, the two Destouches, Paulette Destouches-Février and Jean-Louis Destouches, thought that they had reached the very root of the meaning of quantum theory thanks to all these theorems and these processes of reconstruction of the theory. And they said what follows: every characteristic of the quantum theories derives from first principles. Now, with the exception of the second principle, the principle of subjectivity or contextuality, these principles underlie all the physical theories. If instead of the second principle, we retain a principle of objectivity, namely existence of state quantities, we obtain classical theories. But if we retain the principle of subjectivity, namely contextuality, we get quantum theories. So they said, the mystery of quanta disappears. The quanta originate in the inexistence of a fully objective external world independent of the way one makes experiments on it. This is enough to explain quantization, wave-like behavior, and all the other characteristics of quantum theories. We have disclosed the deeper meaning of quantum theory, they said. Okay, so clearly this reconstruction of quantum theory works as a transcendental argument. Now, recent reconstructions are not so far from this initial reconstruction of Jean-Louis Destouches and Paulette Destouches-Février. First of all, they start from usually an operationalist or instrumentalist or informational basis. And then you see that there are axioms of contextualization and axioms of decontextualization. For instance, Rovelli's axioms that there is a maximum amount of relevant information that can be extracted for a system is precisely an axiom of contextualization. And there are equivalents in other authors. And also, if you think of Lucien Hardy's first axiom, it is an axiom of decontextualization, not of phenomena, of course, but of probabilities. And therefore, there is this twofold presupposition, which is contextualization of phenomena and decontextualization of probabilities, which was already found in Jean-Louis Destouches' derivation. So, and this is very similar to Kant's idea that you have to take note of the situation, dispersed creative character of what appears, and then look for a universal, unique, invariant structure, enabling us to best anticipate future appearances, whatever the situation initially adopted. Cubism fits quite well with this scheme, except for the fact that it is an interpretation which is suffused with these ideas from the start, from the beginning. It's not just quantum mechanics that is derived from this first principle. It is an interpretation of quantum mechanics which incorporates these assumptions in its from the start. So it's even more fundamental, I think. So, for instance, in a few words, quantum cubism says, if I just quote Chris Fuchs in a very recent paper of his, quantum theory guides us or guides its users in how to better gamble on the personal consequences of their actions. So if we deploy this sentence, we find that the starting point is a methodological instrumentalism, even though it's a reluctant methodological instrumentalism. We'll see why. The second point is that a deep form of contextuality, namely the idea that there is no pre-existence of phenomena which is supposed. And secondly, there is the striving to state and unify the norm of anticipation. For instance, in this sentence of the same paper of Chris Fuchs in 2000, this year, in fact, you see the following idea. The way quantum theory completes its normative guidance is by suggesting the agents strive to find a single quantum state assignment row such that his declared probabilities may be calculated according to the Born rule. So you want a single quantum state assignment row, and this is the norm that you impose to quantum mechanics. Now, there is also an attempt, as I said, it was Cubism is a reluctant instrumentalism because it also wants to say something about reality out of the constraints that are imposed to the instrumentalist frame of anticipation. And Chris Fuchs explains that very clearly in this sentence. If something is to be inferred about reality from the formalism, then it has to be done in the way of an archaeologist. Why did this civilization design this tool for the terrain it lived in? What are the extant conditions that made quantum theory as a tool the natural choice for agents to gamble best with reality? So out of the constraints that are imposed to the gambling in which quantum theory consists, you may perhaps derive something about reality. Now let's ask, among the two main clauses, namely contextuality, relativity, indivisibility of phenomena, and second, unity and coherence of the rules of gambling, which one may express obliquely something about reality? Obviously not the first, obviously not unity and coherence, because unity and coherence is our condition for extending the scope of our gambling beyond one particular instant and place. But contextuality, relativity, indivisibility of quantum phenomena is an incontrovertible fact of us in nature. Okay, but it's a negative fact. You say something that nature is not. Nature is not separable into a subject on the one hand and an object on the other hand. And therefore, the teaching of quantum mechanics about reality is essentially negative. And this is a little bit what Chris Fuchs says in this sentence. The first phase of Cubism might be likened to a grand exercise in apophatic method. We won't yet tell you what reality is, but what it is not. And here is an illustration of apophatic theology. Finally, I will conclude with this slide about the fact that, nevertheless, Cubists think that they have found a way to say a little bit more about reality than just what it is not. It is, I would say, not only contextuality, which was retained as a unique, important clause by Jean-Louis Détouche, but also what measure of contextuality is built into the quantum theory. And this is expressed by certain characteristics of the Born rule, which were usually overlooked by other reconstructors. And this measure of contextuality, which is built into quantum theory, and which is implemented in the form of a purely probabilistic form of the Born rule, is precisely what tells us something about reality according to the Cubist school. So I don't have a specific conclusion, but the general idea is the remarkable interest of the reconstructions of quantum theory to unfold and unpack the meaning of this apparently obscure theory, but which is in fact not obscure at all. In fact, probably it's the clearest theory which has ever been formulated in the history of physics. Thank you very much for your attention, and I hope there is time for questions.
Okay, Michel, thank you so much for the talk. So we now have time for questions. Yeah.
So I wonder, wow. I wonder if you have any comments on, or if you're familiar with the so-called general probabilistic theories formalism, which seems to me also to embody some of the characteristics you talked about in a very abstract way without imposing too much more, namely having alternative contexts and then describing how you anticipate these phenomena in terms of probabilities.
Yeah.
So what is it that Cubism adds or aims to add to that very weak formalism, which I think captures some of the ideas you talked about, but is there any specific ingredient that you're looking for that is essentially quantum, or perhaps that was already identified by the Détouche-Février or others?
Yeah, well, probably the difference between...
Michel, could you repeat?
Oh.
Now it
Yeah.
works.
It works? Yes.
Yes.
Good. Probably the difference between Cubism and all these, these attempts at reconstructing quantum theory, including by a generalized probabilistic formalism, is the way Cubism incorporates the reconstruction from the start, instead of doing that retrospectively. But maybe if Chris is in the room, he might answer this question, this precise question about the difference more precisely.
That's not fair. You're the speaker.
Yes, I know. But to defend Cubism, I think you are the most appropriate person.
So Michel, now we hear you. Now we hear you. So maybe you always wait 5 seconds after we have spoken so that we hear you, because the first 5 seconds we don't hear you.
Ah, okay. Yes, I think that about the difference between general probabilistic formalism and Cubism, I have no specific ideas. And that was the reason why I was suggesting to ask Chris.
Okay, do we have further questions? Yes. So this question comes from Mike Kufara.
Thank you for the talk. I felt like I was able to follow along reasonably well but then I was a little confused on the very last slide with the quote from Détouche-Février with the question, what must nature be, et cetera, et cetera. It seems to me that it kind of goes against the story that you were trying to tell in the earlier part of the talk. Doesn't it seem like a wrong question to ask?
No, it's...
And again, Michel, please wait 5 seconds before you answer. So now it should work.
Yes, thank you. Yes, of course, you may have the feeling that, for instance, the set of transcendental arguments which were developed earlier in my talk were explicitly declared to have no ontological import. And then, to a certain extent, this is the program of Cubism, to try to go beyond this limitation and try to extract some information about nature from the constraints that are exacted on the norm of anticipation. Okay, so is there a contradiction? I don't think there is a contradiction, because in both cases, you can say that the theory describes nothing about reality. Yet, the very fact that some norms are imposed and that the norms are not completely arbitrary may be a very indirect effect of the situation in which we are immersed, that we call the world, the universe, or nature. So it is, in a certain way, there is at the same time a negative statement about any description of reality, and the awareness that what we do is not completely arbitrary. For instance, when we say, oh, for instance, we have a very good adaptive behavior. This good adaptive behavior describes not something that we are adapted to, because in fact, what we do in this environment that we explore is triggering a certain number of phenomena. And therefore, we are adapted not to what there is out there independently of us, but what co-emerge with our action. Yet, overall, in this pattern in which there is co-emergence of phenomena with our action, there are certain norms of appearance of this phenomena that we implement in our norms of anticipation, and that can teach us something, albeit indirectly, about this overall process of which we partake. This is the very difficult and very, I would say, slippery intermediate position in which Cubism is trying to bring us. I think it's sound, but it has to be explored further.
So this question comes from Madi Khalili.
Thank you very much. Thank you very much for this very interesting talk. I agree that the philosophical foundation of Cubism can be understood based on a Kantian view of, or I would call it perspectivism, Kantian perspectivism, and some elements from pragmatism. So I liked the talk very much. My question and my thought is about transcendentalism and that transcendental approach. What is strange about transcendentalism for me is that according to this approach, we attribute different categories and a priori conditions to humans. So we can see that in the history of science and in scientific practice, there are a plurality of scientific theories and models. So it seems that the result of this approach is that we should attribute different categories, perhaps sometimes contradictory categories to human beings, just because there are different theories in the history of science and even in one period of the history of science. So there are different, or the plurality of categories that can be attributed to human beings, which is strange, I think, because it seems that human beings are the same in their way of understanding the world. And it's strange to attribute different categories to human beings. Thanks.
Oh, thank you. Okay, you tell me when I can speak and when
please,
you hear me.
Michel, please, now we can be.
Okay, so yes, you're right. There is something that has been criticized, especially in Kant's way of deriving the conditions of possibility of human experience and then the conditions of possibility of Newtonian mechanics. People said, okay, but these are not fixed categories, because when you change theory, for instance, you go from from Newtonian mechanics to relativistic mechanics, or from Newtonian mechanics to quantum mechanics, you have to change these a priori conditions, and therefore they are no longer a priori. They are, as Reichenbach said, relative a priori, relative to each step of the history of science. So it looks like you have something which is no longer a priori, which is not fixed at all, which is historically drifting, and so on and so on. So how can we cope with that? First, the first possibility is to accept this relativity of a priori, like in the work of Reichenbach and then Michael Friedman, for instance. The second idea, and this is the idea that I favored in this talk, is that beyond the Kantian a priori, you have an a priori of a priori, which is much less historical, I would say, maybe not historical at all. It is the claim of unity, the demand of unity, rather. And this was exactly what Hermann Cohen in the 19th century was advocating, namely the true Kantian a priori, which cannot be removed by any new development of science, is the human requirement of unity of the tool of anticipation of phenomena. And very interestingly, you see, and you have seen, I think, from my talk, that one of the basic clauses out of which quantum mechanics can be reconstructed, it has been done by Jean-Louis Détouche and by many other reconstructors of quantum theory, is precisely the statement of the unity of the tool of anticipation. Therefore, quantum mechanics looks like a much more fundamental theory than Newtonian mechanics, because it relies on not on some a priori structures of the experience of objects, which is after all contingent. Phenomena might not be organized into a set of objects, but it relies on the underlying condition of possibility, which is unity of anticipation. So I think it is a way to overcome the historicity of the a priori conditions.
Okay, Michel. So I have a brief question.
Yes.
So you quoted a paper from 1946 that was co-authored by Paulette de Douche-Fébrier and her husband.
Yeah.
And it had this line, "The mystery of quanta disappears," which seemed to be very little conditions, like some non-objectivist realism. So my first question is what is the name of the paper, and did you translate it, or is it translated into English?
No, it's not translated into English. It's a paper in Compte Rendu de l'Académie des Sciences, so the French Academy of Science. It is easily available, and it's only 4 pages. So now it should be very easy to translate.
Okay.
The quote I gave was my translation.
Okay, thanks. And I mean, yesterday, Julian Toda, in a different context, he sometimes said that something sounded too good to be true. So this seemed to sound too good to be true, right, for the stuff that you are working on. So how rigorous do you think is this kind of argument that we find in this paper, in this short paper?
No, I think it's just, you know, it's one of these arguments, similar, for instance, to von Neumann's arguments against hidden variable theory, that is perfectly rigorous, but with assumptions that are a little bit too narrow, and that's the problem. Yet some of the conclusions are not so far from many of the present reconstructions of quantum theory. So it would be easy, I think, to show that the theorem that was demonstrated by Détouche and Détouche-Fébrier is just a theorem that holds only for some conditions that are narrower than the ones that are required for quantum theory to work. Yet there is something to be drawn from it, and I leave for your reflection and discussion.
Okay, thank you so much. So let's thank again, Michel.
Thank you.